everyone, and welcome to the Plymouth Antiquarian Society webinar. I'm delighted that you could join us for this discussion on historic building technology and the importance of preserving historic houses. My name is Ann Mason. I'm the Executive Director of the Plymouth Antiquarian Society, which owns 3 historic houses in downtown Plymouth, Massachusetts. Historic preservation is one of the core components of our mission as a nonprofit organization. And I'm delighted to have Lee McColgan as our presenter today. Lee graciously agreed to switch from doing this as a live presentation, which it was originally intended for our potluck supper, which was supposed to happen this spring. Of course, because of the coronavirus pandemic, we couldn't have that meeting in person. So we are offering this webinar as a virtual alternative. Lee is a lifelong builder. He discovered the art of timber framing about 10 years ago, which ignited his passion for all historic trades. He primarily practices traditional woodworking, both carpentry and joinery. So he builds reproduction furniture, and he also works in the preservation industry locally. Lee is also the founder of Helve, which is a historic trades company focused on the building arts. I first met Lee when he was helping another local preservationist, Michael Burry, plaster one of our ceilings at the Hedge House here on Water Street in Plymouth. And he's helped us with other smaller projects since then. And he also had a starring role at our Antiquarian Summer Fair last summer when he brought his portable workbench and was demonstrating some woodworking. So Lee, thank you so much for being here, and take it away.
You're welcome. And can you hear me?
Yep.
Okay, perfect. So first off, thank you everyone for dialing in. I know that we're all very busy. I know you have lots of things to do. We appreciate that you have taken the time to join us tonight. So I'm in the preservation trade, as Ann just said. I've been fascinated with old houses, old buildings for a number of years. And a while back, I really started to wonder, why have old houses lasted so long? And thinking forward, how can we build houses today that will last for centuries ahead? And that's really what I wanted to talk about. But before I do that, I'll share a quick story. A number of years ago, I was in, of all places, Lincoln, Nebraska, and I happened to have a meeting there. And I got to my meeting, I was a little bit early, had some time to kill, and I noticed the venue next to where my meeting was advertising that they were having an open house, and they had had some Tibetan monks there visiting. And being a curious person, I thought I would pop my head in. And I walked in the building, and I saw this. I saw a number of these monks, and they were huddled over this board with a scribed geometric pattern in it. And they were taking these little funnels full of colored sand, and they were just gently tapping the sand onto this board into this extremely intricate sculpture, which is fascinating. And apparently they do this for, I want to say it was at least a week. They worked around the clock creating this sand structure. And I learned a little bit more about it. If you're not familiar with this, it's called a mandala. And what I learned that's most fascinating is when they're done with this sculpture, they literally take it and they go dump it in a river. So they it's a ritual. They're building and they're destroying. And it's a reminder to them of the impermanence of everything in the world. And it's a mental exercise to help them not get attached to physical things. Now, this stuck with me for maybe an obvious reason to some. I am someone that, one, I build things. And when I build things, especially if I put that kind of time into it, I want these things to last forever. I've also dedicated my life's work to preserving old structures. So I do not want to accept that these things are just going to rot away. I'm trying to keep them around as long as I possibly can. So clearly I'm not a Buddhist, but I have thought a lot about the philosophy. Really, though, why I tell you that story, it prompted the question for me to think about, which is, why do I want to preserve these old things? Why can I not accept that, these old structures are eventually just going to rot? Why do I want to keep them around? And to me, when I think about preservation, not just of the structures themselves, but also of these old arts, I don't like to see these traditional building arts get lost to time. It comes down to me to four basic reasons. And I summarize them with four words that start with an S. I say site, strength, sustainable, scholastic. So what do I mean by that? And most people dialing into this webinar probably see the value in preserving old houses. So maybe I'm preaching to the choir, but to me, it starts one with what we see. Aesthetically, old houses, for me anyway, they've always been appealing. There's a draw there. This was a conference I went to out in historic Deerfield. This was just a picture I took of a house out there. But whenever I see these well-preserved old historic structures, I'm always drawn to them. And I don't think I'm alone. I think there is some aesthetic beauty that is good for our communities, not to mention having these nice, well-preserved historic houses that have character that people love to see. It draws people. One, that's good for our property values. But really, secondly, it just adds something to our community. There's a beauty there. And again, I've often thought, well, why is that? And one of the things that old builders, I think, incorporated maybe a little more today than in years past is a more predominant use of geometry. And it's not to say, obviously, a lot of architects are using geometry when they build structures, but I don't think we see it as much in residential construction today. And geometry goes as far as even the subtleties of the fenestration of the building. So meaning where the doors and the windows are placed. So this is just a couple examples of a couple structures where clearly the doors and windows were not just placed randomly. There was some thought put into that, and it's not a pattern that you would notice. But if you look at those connecting regulating lines, when you've kind of figured that out, and I do this all the time, I drive around and I study old structures and I look for where those regulating lines connect, and I look for these subtle patterns that before I had learned about this concept, I really didn't think much at all. And I think one of the appeals, one of those draws is that one thing I do know about how our minds work is we love patterns. We're just drawn to patterns. So that's just the one element. Strength, and maybe this is more, speaking to why I don't think this technology should be lost, why I think we can continue to incorporate it in building today. I live in a house that was built in 1702. It's still standing. It's in wonderful shape. For anyone that knows, the oldest timber frame structure in the United States, it's the Fairbanks House in Dedham. It was built in 1637. And equally as fascinating, the oldest timber frame structure in the world, coming back to our folks in Tibet, is a monastery there that was built in the 7th century. So in terms of the quality of the end result, you get a extremely strong, durable product. So some of these technologies it's still to me a great way to build. Sustainable, we're dealing with these were vernacular houses, so often they were built with, and we didn't have the technology in New England that we do today. So they were minimally processed natural materials, hewn beams, iron, mortar, plaster, brick, which is clay, sand, all these things fired at low temperature. So these are very natural, minimally processed materials. There's no petrochemicals, and they tend to be good for the environment and sustainable. And then I think there's a scholastic motivation for an interest in preservation. And maybe this is a selfish one for me, but I see these historic houses that sometimes will get bulldozed that maybe could be repaired. And, I always think, well, we're losing this original fabric. And for someone like me that wants to preserve these, not only these structures, but also these lost arts, I need structures to study. I love to go poke around old historic houses and really study how they were built. And if we lose the physical examples, the more and more we lose, the less actual, the less of a database we have to really study, for lack of better terms. So this is a trip I took. My wife and I, Liz, took a trip to Scotland. And in Scotland, there's a nonprofit organization called the Scottish Lime Centre. And essentially, they house samples of traditional lime plaster, which I'll talk about, mortars and plasters that have come from all over the world. And this is my good friend, the executive director there, Roz Artis, who actually has taken a sample of a plaster and broken it down. They use muriatic acid essentially to break the sample down, and they can analyze what goes into that sample. And they keep a database. So even in some cases where structures are lost, we can still preserve some of the materials that were used when these structures were built. So site strength, sustainable, scholastic. So I'll talk briefly about what I think is the big difference in old structures and new structures, and then I'm going to talk about a couple of the different building elements. So in my opinion, the biggest difference between old buildings and new buildings is permeability. And you always hear that old houses need to breathe, and that's what I'm talking about, absorbing and evaporating moisture. And what I mean by that is, here's a side-by-side illustration of how permeability relates to a historic structure and a modern structure. And again, there's nothing wrong with how we build houses today. Both have strengths, both have weaknesses, but they're a little bit different. And oftentimes they don't mix. So because these historic structures are built with natural materials like brick, stone, and wood, which all tend to be very porous, when it rains, these structures are going to soak that moisture up. And that is one of the negatives. Again, living in a house built in 1702, when it rains inside the house, it gets clammy. Some people don't like that, but we tolerate it. But the thing about these natural materials is the building can soak up that moisture, but when the sun comes back out and things dry out, that moisture is going to evaporate. It's got plenty of paths to exit the building, and things dry out, we move on with our lives. If you contrast that today with how we build structures, generally we're trying to create complete moisture barriers. So think about, laying a sheet of plastic down and then pouring a concrete slab in the basement, or think about wrapping a house with Tyvek, with a plastic type material before you put siding on it, or think about the fiberglass gutters, roofing systems that are going in, or vinyl siding, things like that. So these products are designed to create a complete moisture barrier and just keep the water out entirely, which also works. When it rains, you don't get that damp, clammy feeling in the house. But here's the negative. From my experience, in time, water always tends to find a way in. And the issue with moisture barriers is when that water gets in, it gets trapped. And when it gets trapped, that's when the microorganisms, the fungus, the insects, are going to come and deteriorate that house at a much accelerated rate. One of the other big things I see is, in terms of a negative, is mixing these two technologies. So taking an old historic house and then using these moisture barrier systems on it, because you might, a stone foundation is still going to soak up moisture from underneath the house. And if you put plastic siding on it, it has fewer places to escape. So sometimes mixing these two technologies will trap that moisture, and it will accelerate the deterioration of the structure. So that's probably the biggest thing to consider, and something I think about often when dealing with these structures. So I'll jump into, I'm just going to look at three of the building elements. There's more things that I can talk about, but with limited time here, I'll try to get through this in under an hour. Again, I know everyone's very busy. I'll talk about three: woodwork, masonry, and ironwork, and I'll pause at the end of each one of these sections. If anyone has any questions, we can field them then. So I'll start with woodwork. This is a plate, an image from Diderot's Encyclopedia of Trades. That's circa the late 18th century. So you've got some carpenters out here cutting mortise and tenon in some beams, just out there working in the yard. You see a pit saw in the back there. So I'll talk a little bit about the wood structure. It's a timber frame for those of you. I'm assuming most people are familiar, but the timber frame structure. If we were to take a first period house in New England and strip off all of the sheathing and clapboards and shingles and whatnot, plaster walls, all that, we would see this. So this is a very typical example of a colonial English timber frame structure. So these are heavy duty timbers. They're squared, they're hewn with a hewing axe. Oftentimes they're made of oak, which is extremely rot resistant. I'll talk a little bit about that. But again, for their vernacular structures, so whatever was available, oak would be preferred, but you'll see eastern white pine. You'll see other wood species in the frames, but predominantly oak and pine is what I normally see. But this whole structure, it's all tied together with intricate mortise and joinery. And it's an extremely, this whole structure is working as one solid unit. It's an extremely durable way of building. And I won't bore you with every little detail on this picture, but I will talk about one element of this style of joinery that I think most people are familiar with. If you ever walk into an old colonial house and you look in the corners, if you look at the posts, oftentimes the posts are still exposed. You can see them in plain sight, and you'll see this heavy duty post with a lot of material at the top that gets a little thinner towards the bottom. And that is, most people call that a gunstock post. The English call it a jowl post, as it has a jowl, it has a cheek to it. But there's that extra material on the top. So if you're not familiar with this, this is called the English tying joint. And the reason that you have that extra material on the top of that post is if you look at that lower piece, the lower drawing in this image, you've got to have room to cut two different tenons for what's called the wall plate and the tie beam to fit into. So you've got a wall plate that sits on the post. You've got a tie beam that sits, you can't see the wall plate, that's not in this image, but you've got a tie beam that sits on top of that. Oftentimes, if you look at number 4, the little arrow there, it oftentimes has a dovetail joint there that is pulling the wall plate in place. And then you've got a rafter that is mortise and tenoned, and it's all pegged together with wood pegs. This is an extremely, extremely durable way of building. And I'll give you an example, just timber framing in general. Here's an example of, it was a house that the English tying joint had failed, not because structurally the way it was built, it failed because at some point in time, the roof was probably let go, and it got excessive moisture, and the bugs got to it, powder post beetle. And the corner post had just completely rotted out. So the tie beam, the wall plate, that's the beam you see on the right, the post and the rafter were completely rotten, completely gone. What was amazing to me, this was all covered up with a bunch of paneling too, which is one way to address a problem. But what was amazing to me is when I tore the paneling off and came across this completely rotted, failing element of this frame was still standing up just fine. Largely it was the sheathing boards, but these frames can endure an extreme amount of rot and still hold up. And again, this was an 18th century house, so hundreds of years later, still standing. Here's the other thing about why I wanted to show you this repair. The other thing about rot like that in a frame, that does not mean that you need to remove that entire frame or bulldoze that entire part of the house or the entire house. You can do repairs. So this is an example of using a series of scarf joints where I fit these different repaired patch pieces. I fit these patched pieces to essentially repair the frame and preserve most of the frame and keep it largely intact. So that piece of the tie beam, that's just before I dropped it down into place, and then I drilled holes and pegged that together. Did something similar with the rafter. And of course, just to match, I believe an in-kind approach to preservation. Whatever, I do my best, whatever was there when the structure was built, I do my best to copy that. So then you have everything working together the way it was meant to when it was originally constructed. And aesthetically, you get something that matches. So I took a hewing axe and hewed the beam. It's a double beveled hewing axe, so it leaves these little scallops in the beam, but that matched what was originally there. So aesthetically, you get a match, and structurally, you get something that should last at least for a few hundred more years. So I'll talk briefly about old growth, old wood and new wood. So people often hear, well, their old growth timber is better. So what does that mean? Why is that? Unfortunately, all the old growth timber in New England was long ago cut down. when the Europeans got here in the early part of the 17th century. From what I've read, there were examples of pine trees that were 400 years old. And sometimes you can see that in just these massively wide floorboards in some of these historic houses. Unfortunately, most of that, excuse me, all of that old growth lumber was cut down. But you still can get mature second growth lumber. So what's the big difference here? I'm showing you a cross-cut section of two pieces of pine. One is older growth and one is a new piece of pine. And what you'll notice immediately is the annulary rings, the growth rings, on the old growth piece of pine are very tight. And on the newer growth piece of pine, those rings are spaced out tremendously. So why does that happen? What does that mean? Why is one better than the other? So when we say old growth, we're talking about trees that are growing in a very dense forest. And when a tree is growing in a dense forest, it is competing aggressively for water, nutrients, sunlight. And a young tree will grow very, very slowly. And what it's waiting for is an older, more mature tree to fall down, creating an opening in the canopy above so it can shoot up there as fast as it possibly can, because that tree wants the sunlight for photosynthesis. But when it grows in a dense forest where there's lots of competition, it's growing very, very, very slowly. And because of that slow growth, what you get is an end result. You get lumber that has a much higher specific gravity. That's how we measure density. But it's very, very dense. And what that density means is it's going to be a lot, structurally it's stronger. It's also going to be a lot harder for insects and powder post and fungus to rot that away. In contrast, if you think about some new growth lumber, essentially what's happened is a section of forest is clear cut and a bunch of new trees are planted, and those new trees don't have that same competition. They can get all the sunlight and water they want when it rains, and what happens is they shoot right up and they grow very quickly, and that is why you get this less dense building material. And because it doesn't have that density, it's going to rot faster. So again, all the old growth lumber was long ago cut down in New England, but you still can find mature second growth, or at minimum, if you're looking for lumber, look at the growth rings and look for wood that's grown a little bit slower, that's a little bit more dense. You're going to have a better end result. This is a cross-cut section of oak. So again, I mentioned that the preferred building material in New England for framing was oak. And the reason for that is preferred for shipbuilding and house frames. And the reason for that, one, it's also very, very dense. It's much denser than pine, hence a hardwood versus a softwood. But oak is very porous. And if you look very closely at the pores, so on the left, you just see the cross-cut with the pores. On the right, what you're seeing is an up-close magnified image of those pores. If you look closely, oak has something called tylosis present. It's a natural resin material. It just occurs naturally, and it literally acts like a resin. It fills those pores. Red oak, as opposed to white oak, does not have this. Why? There's a certain point where I don't know why. That's just the way it is. But white oak has this natural resin that's plugging up those pores, which, if you think about coating anything with an epoxy or a resin, it's going to keep the water out. So it is just naturally rot resistant. And again, that's why it was preferred for house framing and shipbuilding. So I'll show you a couple examples of framing repair I did. This is a job that I headed up and did all the work on. This was out on Nantucket. This is one way to repair a rotted sill. And again, this is more timely. It's going to be more expensive. I understand why everybody doesn't take this approach. Oftentimes, if people want to repair a rotted sill, carpenter will just cut the rotted material out and take a stack of treated pine and just literally, put the stack in where the rotted material was and toenail the pine into the existing sill. But if you have the time and if you want to repair that's going to last a little bit longer, this would be the way to do it. So using a couple of screw jacks, and Ann had mentioned Michael Burry. It's something I learned from Michael Burry a number of years ago. Using a bracket bolted to one of the posts, and a screw jack and a beam. In this case, we call it a strong back. It's two beams screwed together. You can actually take the weight off of the sill. You can very slowly lift that house up, which was done here. And then I removed the courses of brick, cut out the rotted wood. So here's a side view of that. And you can see all those posts and all those studs, they have their own tenon joint. They are tenoned into that sill. So this is the other advantage of approaching a repair like this. If you just put the pancake stack of treated pine in there, you're gonna lose all that mortise and tenon joinery that's helping to keep this frame working together as one unit. In this case, I was able to remove enough of the brick to make a repair piece. Again, this is a scarf joint that's called an edge haft scarf joint with a bridle abutment is the fancy term for that. But it was able to actually get that repair piece in place and then lift it up into place, maintaining all that joinery. So that's the two pieces of the scarf joint coming together. And then here's what it looked like when it was all in place. And then I did not do the masonry repair on this. My good friend Colin Evans did that. But then the blocks were removed and the masonry was rebuilt. And again, this is a repair. Now all that original mortise and tenon joinery was maintained. This is a repair that I would expect to easily last another couple hundred years. This house was built in the early 1800s. So I'll pause there. Anne, can you hear me? Everything's working well there? Okay.
Yep. You have some questions too, Lee. If you want to answer these ones?
Yeah. Why don't we throw a couple at me? We'll see if I have the answers to them.
Sure. So one of our questions is, are some of your woodworking tools very old? So I know you were talking about using the old techniques, but do you also have old tools?
Yes. So when I can, I do prefer to use old tools. There is I'm not a collector, but every now and again, you know, whether it's at the flea market, you find that great antique tool that you just, you can't bring yourself to actually use it. You want to preserve it. Again, I'm not a collector. I generally don't buy tools that are going to be, collector pieces. I buy old tools that have some wear that a collector probably wouldn't find very attractive because I want to use them. So absolutely on that job, the framing chisels I have, they're old. They're the other thing about, I'll do a little tangent here, framing chisels. So modern day framing chisels are made of one solid piece of high carbon steel. Old framing chisels, or really any chisels, were made mostly because carbon steel, which is harder steel, it's got a higher carbon content in it. It's much stronger, but it's also more brittle, and it was more expensive back then. So oftentimes, most of the tool would be made of a softer wrought iron, and just the end where the tip would be, where you need a sharp edge, would be made of a higher carbon steel, and it would be forge welded together. And it's interesting, you wouldn't think that would make a big difference, but when you work with these tools long enough, you start to actually notice a difference. That softer wrought iron tends to absorb a blow of a mallet just a little bit easier. I split wood with a froe and a mallet from time to time. Where you literally take shingle froes was the old way of riving stock, splitting wood, which essentially is an elongated piece of bar stock with a slightly tapered edge. And if you haven't seen this, you take a big mallet and literally give that a whack along the radial plane of the wood and split that wood open. And I've used shingle froes that are made of modern high carbon steel and old shingle froes that are made of softer wrought iron. And they absorb the blow differently. Less of that blow will reverberate back into your arm. It's just a more pleasant experience. So sorry, that was a long-winded answer, but I do prefer to use old tools. But if they're really nice, I'm not going to abuse them.
Right. Well, I mean, it just goes to show that recreating or preserving these crafts are important because you get that human perspective of what it's actually like to do this work, that, different building techniques that have been used for centuries, that is part of the human experience. So you are, recreating that experience and learning a little bit, not just about the houses, but about the people and how they perhaps used tools and shaped tools in order to make work less labor intensive or something like that. So it's all part of that.
It's amazing too, the little things. So when you can study these old building technologies, but then when you actually go do it, and then when you actually go use old tools and you get that full experience, then you go back to these old houses and when I go in old houses now, there's so much more subtle little detail that I notice that without that experience, I just never would have caught before. Even little things, when I study hewed beams, sometimes I'll see these little streaks in the beam. They look like little rainbow shaped arches. And I never would have known what that was until I started doing this. And one day while hewing a beam, I think I had nipped the log dog or hit a piece of metal, and I got a little chip in the edge of my hewing axe. And if you hew the beam with a little bit of a nick in it, it will actually leave this little track mark. And I thought, oh no, I've got to take this thing back to the grinder and get rid of that nick. I don't want these marks all over the beam. But I'll go and I'll study the framing in these old houses, and sometimes I'll see those track marks, and that tells me, wow, that person hewing that had a big nick in their tool, and well, it didn't seem to bother them, so maybe I shouldn't get so bent out of shape about it.
All right, we have a couple of questions about materials. So Brian Bello is asking, does anyone still grow trees in a fashion that encourages the slow growth that you talked about earlier?
Yeah, so probably the best book on trees, I believe it's called you might have to fact check me on this. I believe it's called The Hidden Life of Trees, and it's by Peter. I want to say it's a German name. He's from Germany. Wallinger. It's something like that. Don't quote me on that name. But he has written a book. So he managed a forest from the standpoint he was in the forestry industry and managed a forest, and has a really interesting perspective on trees and forests, and how they work, and how we can get better lumber by thinking more considerately about how we clear cut forests instead of just clear cutting and planting and growing again, being a little more selective. So I don't know in this country, where you can find that. If I want something closer to old growth lumber, I'll find a sawyer that understands what the heck I'm talking about. Because sometimes there are still old trees that come down in storms, and sometimes they just get chipped up and mulched, and sometimes you have, some of these, they often are old timers, but you got these folks that understand this concept, and they'll rush and try to get their hands on that lumber and just take it back to a small sawmill and mill it. And those are often places that you can get a little higher quality lumber. If you go into the big box store, I won't mention names of the box stores, but the ones, you're not going to get really great quality lumber there. So I'd start with small local sawyers. But in terms of forestry practice as a whole, it's probably still slow to be adopted, but that's all I can tell you about that.
Yeah. It looks like we've someone who's actually looked up the book, and so is it The Hidden Life of Trees by Peter Wolleben?
That sounds right.
Well,
Yep,
I'm terrible with my German pronunciation. But that's in the chat if anyone's interested, the title and the author in the chat, so you can see that and look for a copy to read. Another question about materials: what kind of wood shingles do you recommend? Red cedar, white cedar, Alaskan cedar? Any thoughts on that?
I usually just use white cedar. Yeah. Yeah, I don't have a lot to add on that. I've just always used white cedar. It's normally what's available, so that tends to hold up just fine.
Okay. Good to know. And then the final question that we have, Ryan Grimm was asking, are you currently working on any structures in or near Plymouth? And maybe that's a question you want to save to the end. I don't know if you're coming to it in the presentation or if you want to talk about it now.
Yeah, so the project that I'm involved in currently in Plymouth is, it used to be First Parish Church, and again, I know the name was just changed. It's now, the ownership got transferred to the Mayflower Society. I think it's the national, maybe you know this, Anne.
Yeah, the National
Pilgrim
Memorial Monument Meeting House. That's the word.
There we go. So I've been involved. So a guy named Ken Eurasius, who owns a company called Stone and Lime out in North Brookfield, I think is where Ken is. It's a union company. His company came in and they did. This is a stone structure. So his company came in and repointed that, which actually this is a nice transition into the next part of this presentation. But I was able to get to rebuild some doors for that project and some molding. So on the back door, I was able to build and I did use oak. I used quarter sawn white oak. I built a nice frame and panel wood door and did some nice oak moldings. And I've got one more door that I just completed that has to go in. So that would be the most recent Plymouth project I've worked on.
Cool. All right. So the final question that's open right now is the golden ratio present or utilized in the design of these structures?
So I've read a little bit about the golden ratio. I'm going to say that I don't know. I understand the concept of the golden ratio and how that you see that in seashells. There's this mathematical equation. I think it's, oh boy, now we're getting into math. It's one, well, someone can fact check me. It's 1 times 1.6 something. There's a great image of a shell that starts, it's literally square, and then you add that percentage to that square and you keep building this out and it makes this shell type pattern. And I know people that really buy into the golden ratio concept will see it everywhere. They'll look at the human face and they'll say that where your forehead and your eyes and your nose and your lips are placed, there are certain proportions that meet this ratio. Some people are completely buy into that, and some people are skeptical. I only know just a little bit about it. I haven't gone that deep with that one, so I can't say for certain. I can't say for certain that that's going to show up in a lot of early New England structures. But I do see a fair amount of just basic geometry and patterns when I get back to the fenestration, when I look at regulating lines, how windows are placed and things of that nature. So I'm sorry, I'm familiar with the golden ratio. I don't have a lot to add on that one.
That's okay. It's something that we can explore maybe in future talks or webinars for sure. So we have a couple more questions, but do you want to continue with your presentation, Lee, and then maybe come back to questions?
Yeah, just because
I don't want you to run out of time.
Yeah, why don't we try to get through the slides?
Okay.
Let's see. Oh yeah. Let's get through the slides because there's a lot more, and I'm looking at the clock now, and that is going to burn through all the time. So let me get through this quickly, and then maybe we'll get a few at the end. How's that sound?
Great.
Okay, so I'm going to go a little bit faster now with that in mind. Masonry, I'll talk a little bit about masonry. So traditionally, I mentioned this before, but predominantly in houses anyway, you've got stone foundations or brick foundations, and then you've got brick with fireplaces and the stacks and such. But the predominant material used for mortar and then also used for plaster in the walls was lime. And lime, so calcium carbonate is what lime is chemically. What limestone is, so it's a sedimentary stone. So little very microscopic sea creatures in the ocean I'm going to simplify this, but microscopic sea creatures in the ocean die, and the material they're made of sinks down to the bottom of the ocean floor, and it builds up into layers, hence why limestone is a sedimentary stone. And it in time will form something we can use as a building material, as a stone. It forms limestone. And so this happens at the bottom of the ocean, and in time with plate tectonics, continents and things shifting around, some of these sea bottoms essentially get pushed to the surface, and then we can go and quarry it and pull this limestone out of the ground. But seashells are made of the same material that limestone is made of. So oyster shells and limestone are essentially made of the same thing. And that material is calcium carbonate. And while I'll go a little tangent here, if you remember your stones, you've got igneous, sedimentary, and metamorphic. So limestone that continues to be exposed to pressure and heat under the Earth's crust becomes a metamorphic stone. Its physical properties change, and it turns into marble. So marble essentially is the same thing. It's a metamorphic version of limestone. So limestone as itself is a great building material. You think of Notre Dame, which unfortunately there was that fire there recently, but Notre Dame was built predominantly of limestone. So as a stone, it's not going to make a great material for plaster or for mortar. So how do you take stone and convert it into something that's more usable for plaster and mortar? You heat it up. So the image here I'm showing you, it's just called the lime cycle. So essentially, colonial New Englanders would take either big piles of oyster shells. They called these lime ricks. We don't have limestone quarries locally here, but maybe they would import limestone. I'm not an expert there, but they would take either seashells or would take limestone and essentially heat it up somewhere around 900 to 1,000 degrees. And that chemically, it creates a chemical reaction. So that stone itself will convert into a different product. The heating burns off carbon dioxide, and the stone will actually break down into a white powder. And it's a highly reactive substance. It's called calcium oxide. And when you add water to it, so that's very volatile. When you add water to it, it'll give off a tremendous amount of heat and steam, but will chemically convert again. That's called slaking to calcium hydroxide, and it's a much more stable product. But that now becomes a soft white putty, and that's what was used mostly. In some cases, clay would be used, but in early New England anyway, it was the preferred material for lime and plaster. That's what you have. You've got slaked lime. It's a lime putty. So once it's applied, now it's in a form that you can work with it. Once it's applied, it begins reabsorbing that carbon dioxide from the atmosphere, and it hardens up again, and it turns back into essentially calcium carbonate or limestone. So it's a material that it has a cycle. You could chip all the old plaster off the wall and heat it up and convert it again and turn it into putty and use this over and over again. So it's really interesting. But that's what was used. And just for fun one year, we had hosted a holiday party, and we had some oysters for appetizers. And after the party was over, I had some of these leftover oyster shells, and I decided to take them and put them in a cast iron skillet and put them in a small gas forge and heat them up. It wasn't a terribly calculated scientific experiment. I couldn't tell you the exact temperature I got them to, but that forge I know will get up to around 2,000 degrees, I think a little over, which is forge welding temperature for blacksmith terminology there. But we definitely got it over 900 degrees. And those shells, certainly, sure enough, they broke down into a white powder. I added water to it, and sure enough, it reacted, it heated, it bubbled up. So I had a good I knew chemically I got a good reaction out of it. And I made essentially lime putty from oyster shells from our cocktail party. So next time you have a cocktail party, there's something to do afterwards. So I'll talk a little bit about that. I've done a fair amount of traditional plaster work in recent years here. And most recently, I just redid a plaster ceiling. This was actually in my house. It was in my bathroom. And if you ever break up old chunks of plaster in these old buildings, you'll see hair in it. It was called horsehair plaster, although I believe they would use horsehair or I think also goat hair. And I see that in my 1702 house. I see that not just in the plaster walls. I see that in the mortar, in the foundation where the pointing was done. They put hair in it. I actually just did some repairs on my chimney. I was up on the roof, and there was a render of plaster over the brick chimney, and some of the original render was still there, and that had hair in it too. So they added hair to not just plaster, but also the mortar. And what the hair does is, so the big issue with traditional plasters, they're a little finicky when it comes to moisture. And if you think about wet putty, it's really tacky, so it'll stick when you apply it. But what you risk is if you apply it to a very dry, porous material, it's going to suck all the moisture out really quickly. Or if you apply it on a hot sunny day, the moisture is going to get sucked out of it really quickly. It's going to dry too fast. And when it dries, it shrinks because now it's not saturated with water. And when it shrinks, you lose that really tight bond that holds everything together. So you want to reduce shrinking as much as you possibly can. So the hair itself, in addition to creating this fibrous substructure that binds the whole thing together, the hair itself is not going to change its volume. So putting hair in plaster also reduces the shrinkage, and it makes sure that your plaster has a better bond. So we own a farm property, and we have horses because you can go buy, usually they sell goat hair, and I think it comes from China. And I looked into that, and I said, you know what? I've got horses. Why the heck am I out there buying animal hair? So in the, my wife, she's wonderful. She puts up with all the shenanigans. In the spring, when the horses were shedding their long winter coats, I had her collect a bunch of the hair in a bag. This is a friend of mine, Max, who's helped me do some projects around the house. And we took our lime putty and sand in a 2.5 to 1 ratio and mixed it up. And then we added our hair, and now we've got horsehair plaster. So this is the bathroom ceiling. I remodeled a bathroom, always trying to find ways to preserve the original fabric of the structure and also keep it modern and have something that's livable. And there was some plaster board. The original horsehair plaster had long been torn out, and there was some plaster board in its place. And mildew was starting to form on it because the bathroom gets a lot of moisture, and the previous owners didn't have a fan in the bathroom. Here's the other great thing about lime putty. It is, if you remember chemistry, you've got acids and you've got bases. So lime is a very strong base, so it has a high pH. It's a strong alkali. And what that means practically is living organisms don't like to live on it. So it is a natural anti-fungal material. And an example of that, we had very, very old wallpaper that the glue had long since separated in this bathroom. And, normally when you get that, moisture will build up and you'll get, a little bit of mildew behind the wallpaper. When I finally got to tearing the wallpaper off where the original plaster walls were, there wasn't any mold or mildew behind it. So there's some truth to the fact that it has antifungal properties. So also very, very good. So this is when I tore the modern plasterboard, which is made of gypsum, which is not antifungal. So if it gets really wet, you're going to get mold and mildew. When I tore that out, I was very delighted to find that the original oak ribbon lath was still intact. I did re-secure it with some lath screws that originally would have been nailed in, but re-secured it with some screws, and then mixed up my my lime putty here. And then the trick is just to take the trowel and in a very smooth motion, kind of push it up and push the plaster through those little spaces, those little cracks in the lath. And the plaster actually will get pushed through and it'll curl over. Those are called keys. And that's actually what keeps your ceiling up. So it's not that the lime is sticking to that wood lath, it's that you're pushing that lime through those little cracks. And when it curls over as you push it through, think about, Play-Doh going through that little squeeze, can't think of the word, but the little squeeze thing you had as a kid when you would squeeze Play-Doh through it. Think about that. And that's what you're getting. The lime just curls over, and when it hardens, you've got these nice keys, and that holds it up. So that's me doing the ceiling in my bathroom, and it's held up quite well. So I'll talk a little bit about brick, a little bit about stone, and then maybe a little bit on ironwork, and then maybe we'll go to questions and then wrap it up. So this is things about repointing. So this is essentially an illustration of a brick wall, brick structure. And I'll talk a little bit about the value of lime. So lime, it is a very soft and porous material, and a lot of modern builders don't like to use it. One, it's finicky with water. So if you don't have good moisture control. It'll dry too quickly, and again, it'll be crumbly. But it, like anything, if you understand how it works and know how to use it, it works wonderfully. And the best example of that is all these houses from the 17th century that are still standing today, oftentimes that still have original plaster in them that are holding up quite well. So to me, that's a testament that these are wonderful ways to build. You just have to know how to use them. And again, that part of why I'm doing this is to make sure that we don't lose these arts and we preserve some of these old building arts. So oftentimes what I see is the mortar eventually mortar will break down. So brick, again, it's porous. When it rains, the brick soaks up moisture. And the lime itself is meant to be softer than the brick. And you want it to be softer than the brick. A lot of people that don't like to use lime mortar will say, well, it's too soft. I want something hard like Portland cement. You actually want this material to be soft because very old, low-fire brick is also soft. And you do get a little bit of movement over time. And the last thing you want is for your mortar to be rock solid and movement to start fracturing and cracking your bricks. The other thing about modern day Portland cement, it's very dense. And if you repoint, so the process of chipping out a little bit of the lime that's failed. So if you see the illustration in the center, eventually, the mortar at the edge of the joints in the brick structure, it will fail because it's absorbing a lot of moisture, and weather and water will break it down in time. So it needs to be repointed. It needs to be filled in. And one of the issues I see is these structures get repointed with Portland cement, which is very hard. And what'll happen if you look at the illustration now on the far right is that'll act as a little plug. So when it rains, the soft porous brick will soak up all the water. And back to that permeability issue, when the sun comes out, you want that water to evaporate, and you want it to evaporate back out through the mortar. You don't want that moisture to stay in the brick. Certainly when you get to the cold season where it might get warm enough to rain and then get cold overnight, if you've got moisture trapped in that brick, that's going to do more, that freeze-thaw cycle is going to do more damage to your brick. So what happens is the modern day Portland cement will act as a little plug. And when things dry out, the mortar that should be wicking that moisture is now trapping that moisture, and the moisture is staying trapped in the brick, and that is going to deteriorate your soft porous brick much faster, and then you get spalling. So yes, lime mortar is very soft. You can literally, sometimes break old pieces of it off and crumble it in your hands. That does not mean it is an inferior product. Most of these failures happen not from a compression strength issue, meaning you need something really strong. Most of the failures in these old structures happen because of the damage that moisture does. So that's why it's good to repoint old brick, again, with what was originally used, which normally was lime mortar. Just real quick, a little bit on building with stone. I've got a stone foundation project that I worked on, just a couple of rules of thumb. I went up to the carving studio in Vermont, took a class with a gentleman by the name of Dan Snow, who is a master dry laid stone worker. So how these stone foundations and retaining walls were traditionally built, and the house I live in sits on a stone foundation. The stone was dry laid, so they did not set the stone down, put mortar on it, and keep building. They laid the stones first, and then just the little cracks in between all the joints, or where stones didn't fit perfectly together, the builders would go back and just fill that in with mortar, which again it's called pointing, repointing. So if you're going to lay stone without a heavy duty mortar, well, you need to lay the stone properly so it does not fail just being dry laid on its own. So some of the things to think about, the first one I mentioned is length in. So if you've got a long stone, I think there's an inclination, if it's got a nice long flat end, is to put that facing out because aesthetically that's nice. But you're going to get a much stronger stone structure if you actually take the length of a horizontal shaped stone and put that in towards the center of the structure, length in. And what you end up getting is now stones that are overlapping, and you get something similar to a finger joint for those woodworkers out there. So length in is preferred if you can. Just like bricks, you obviously want to stagger the joints. You don't want big running joints. Your stones, you actually want to have the weight centered so the stones are always, the weight is sloping in, which for obvious reasons, you don't want stones to fall out. But as the ground underneath the stone foundation moves, if the weight is always centered in towards the middle of the structure, with little bits of movement, your wall won't come apart because that centered weight will continue to pull those stones together and keep everything in place even as you get movement. And that's really, not to go off on a tangent, but that's really the genius of these old building materials. Yes, they're not as strong as a lot of modern day building materials, but they're designed to be flexible. You know, things can move a little bit and they don't fail. If anything, they're able to move with changes you know, in the ground that these structures sit on. You want to taper your foundation slightly. If it's perfectly vertical, which is maybe less of an issue with a house that's got weight on it holding it down, but certainly for a retaining wall, if you do get a little bit of a lean from a frost heave or whatnot, it's perfectly vertical. It starts to lean, and you know, you drive around New England and look at retaining walls that, you know, they just start to lean and fail. So if you have a slight taper there, that tends to spread that, the distribution of that weight out and keep things together. Nice even courses. You see all those little stones in the middle. So the big stones are dry laid, but you want to pack in the center of the stone structure. You want to pack that with smaller stones that are called harding. And again, that'll keep things from moving around. And then if you can, put through stones or capstones, stones that run across the complete width of the structure. Retaining wall or foundation in there, which just act as they tie the whole thing together. And you'll see that with you know, brick bonds. You'll see running courses, and then every, you know, 5 or 6 courses, sometimes you'll see, you know, the bricks turned to run again length into the wall, and it's just tying the structure together. So those are good concepts for dry laid stonework. And then I'll just show you real quick. This is a foundation I'm building for a structure. And, you know, oftentimes you can't actually build new stone foundations because modern day building code will require things have to be anchored. And it's kind of hard to anchor to fieldstone. But in my town anyway, structures that are under 200 square feet don't need any permit. So essentially, if you're just building a small shed, you can still build a stone foundation and everybody is happy. So on the left, you'll see before I've pointed, so it's dry laid using those concepts. And then that right elevation of the wall on the right, you'll see I actually took some lime mortar and just pointed it just to secure everything and keep it in place. And when I go down in the basement of my 1702 house, I see essentially the same thing. So building using the same techniques. And again, the fact that it's still working and standing is a testament that this is still a good way to build things. All right, just a few thoughts on ironwork, and then I'm done yapping, and we can take maybe a few more questions and wrap it up. So ironwork, if you ever go up to Saugus, Massachusetts, so the first ironworks in the country is in Saugus. I think it was Lynn then. I think it became Saugus later, but either way, today it's called the Saugus Ironworks. And it was founded, I think, in the 1640s. And unfortunately, it was by Jim. Now I'm testing my memory here, but I think John Winthrop Jr., John Winthrop the Younger, as he was called then, was one of the proprietors of that project. But they built it in the mid 1600s. And unfortunately, it wasn't, they thought it was going to be very profitable. It was not profitable. And I think in 10 or 15 years, it went bust. And the original blast furnace of the ironworks just got abandoned and sat there for a few hundred years. And in the 1950s, there was a scholar that had done some research and got some archaeologists together and went to the site and started digging around. And sure enough, they found lots of remnants of this original blast furnace, largely still intact underground. The water, you see this picture, there's a water wheel that drives this whole operation, drives the trip hammer. The water wheel, the trip hammer, these things were all just left there intact underground. And if you go up to Saugus, you can see the original trip hammer and pieces of the water wheel and the rolling mills. And it's really fascinating if you're interested in this stuff. But how a blast furnace works, it's relatively simple. They basically built a big furnace, a big stack. And you would take the raw material they use for iron ore is bog iron. So essentially it's iron that could be literally found in low-laying bogs, or sometimes picked up on the ground in marsh areas. So it's an iron that's got a tremendous amount of slag and impurities in it. It's called bog iron because they found it in bogs. So they would go collect a whole bunch of this bog iron. They would, what was called a collier would essentially make charcoal. So they'd make a big pile of, they take a big pile of wood and essentially smother it. So reducing the amount of oxygen would keep the carbon in the wood from just burning up into nothing, just ash. So it would make charcoal. They would take charcoal, they would take bog iron, and then they would take a stone that was called gabbro. And it is a stone that I believe it's high in silica. I know what happens is at high temperature, it breaks down, it melts like glass. Just like how you make glass, you take silica and heat it and it melts. And they would put all this in the blast furnace and fire this thing up. And what would happen is the gabbro acts as a flux. So as the iron melts and drips down to the bottom of the blast furnace, the impurities would, the flux would float on the top of this mess, and the impurities would get drawn to that liquid gabbro stone, that liquid glass type flux, and it would literally draw and collect all the impurities. Now, there was still some slag in this iron. It was not slag free, and I'll talk about that in a second. But it would draw most of the impurities out, and then essentially they would open up a small door at the bottom of a furnace that would run to a channel that was literally just sand. It's just a little channel dug into the sand with smaller channels built off of that. So if you look at this image on the lower left where the two folks are working, you see the molten iron that is running to that large channel with the smaller channels next to it. And it looks like little baby pigs that are suckling from the mother sow. And hence that is why that this iron was called, for anyone familiar with this, it was called pig iron, because of that reason. So pig iron is very hard. It's very high carbon content. So that the charcoal, the carbon in the charcoal in this furnace, a lot of that stays in the iron itself. So you get something that's very hard, but also very, very brittle. Heating things up and cooling them down in terms of what happens to the molecules in the iron tends to make it very brittle. The molecules actually will crystallize. So you get a solid crystalline structure, which is hard, but it's also brittle and it's got a lot of carbon in it. So not terribly usable. And the best example I could think of, so if you think about a cast iron frying pan, so very, very good for its purpose. It's good for conducting heat and it's very hard, but a cast iron frying pan is not very malleable. It will not bend, it will crack very easily. So that's essentially what pig iron is, or any cast iron really. So what they would do, if you look at this worker on the lower left of this image, they would actually take the pig iron and heat it up again in what was called a finery. Essentially, they were refining it, hence the name of the term. They would heat it up in a finery, and what that would do is it would burn some of the carbon off, so they would try to reduce the carbon content of it, but it would still be hard and brittle. So then they would take it over to a big trip hammer. So if you look at the workers on the right, you've got that worker holding a big set of tongs, and he's holding this big piece of hot pig iron that's been through the finery. And this trip hammer, which is powered by that water wheel you saw in the earlier image, is literally just a cam on a wheel, just moves this hammer up and down, and it literally will just hammer this piece of pig iron out. When you heat it and hammer it again, what you do, so molecularly it will change again. And it also will, so it draws the steel out, and it will also take, there are still some slag inclusions in the iron. It'll essentially will draw those out into almost a fibrous grain. They're called stringers. And essentially the slag is drawn out and the iron is drawn out, and you end up with a much more malleable material, which is called wrought iron. So if you think about old wrought iron with a grain, the best example, if you ever drive by, sometimes museums or old houses will take an old anchor and they'll just put it outside on display. And if you ever look closely as that thing rusts away, you can actually see almost a grain in the old wrought iron That is all the slag inclusions or the stringers in the old wrought iron. But it tends to be much more malleable, so easier to shape, easier to bend and work with, where the pig iron itself, before that processing, is very hard but very brittle. So what does that mean? Where's the practical application to that? Real quickly, I'll talk about nails, and then I think that's it for the slides. So this is a chart of nails, nail technology over the years. You've got nails that were hand forged out of wrought iron. You've got nails that were cut, which was a process that came about in the early 1800s. And then you have the modern nail, which is wire nails made on a big roll of wire, which originally the French invented. They used to be called French nails, but you don't hear anybody call them that anymore. So I'm still a believer that wrought iron nails are superior in a lot of ways. One, they're hand forged, they're drawn to a sharp point, but they're squared in shape. And what really you get is you get a little wedge that when you hammer it in, boy, it just bites really well and holds into wood. Because if you think about wood over time, you know, as we get humidity and we get a dry season in the winter, as things, you know, the wood's going to expand and contract with changes in the seasons. And in time, what that's going to do is the expansion and contraction of the wood will actually, over time, push those nails back out. And it's true, you know, again, living in a 300-plus-year-old house, when winter rolls around, it gets cold and everything dries out, the little nail heads on the floorboard start to pop out. They poke up. So I either have to go around with a hammer and tap them back down, or stub my toe or catch a sock on them, which is very frustrating. But originally when they went in, and, you know, again, these were put in many cases, the 18th century, you know, they've held up quite well. Where a wire nail just doesn't have that tapered wedge-like effect, and, you know, wire nails, you know, over time tend to get pushed out of the wood a little bit easier. They don't bite quite as well. Your downfall of the cut nail. So when they figured out how to make cut nails, they actually took elongated bar stock that would be the length of the nail, and they developed a machine that would actually cut a little nail off the end of the bar stock. But I'll come back to my point on grain. If you remember, the slag inclusions create a grain in the wrought iron. When you're making a forged nail, you're actually drawing that iron out, and you've got a nail that has that grain working with you. So if you want to clinch the nail or bend it over, it'll bend and it won't break. The cut nail is cut across the quote-unquote grain of the iron. So those slag inclusions are running in the opposite direction. So when you go to bend a cut nail, oftentimes it won't just bend around, it will break because you don't have those nice fibers inside the iron that work together to make the iron malleable. So cut nails were easier to manufacture, but were still inferior for that reason. And then again, most people use wire nails, but I still argue if you can find a blacksmith that'll make you some good forged nails, they work pretty well. So here's an example. I did a repair of a cabinet door and actually sourced some reclaimed antique wrought iron hand forged nails. If you walk around these certainly first period houses, just to give that head of the nail a little something extra to bite into, the builders would take little pieces of leather and cut little squares and punch a hole in them, and then use that as a washer and hammer the nails in that way. And I still have a number of those leather washers preserved inside my house. Again, back to once you start doing this stuff and learning this stuff, when you walk through old houses, there's just so much more you see. It becomes really fun to look for all these little details. So I just cut some little pieces of leather, and I found an old forged hinge on my cabinet door and just hammered it in, and it's holding up just great. And aesthetically, it just matches everything else in the period. So that's it. So I'll come back to why preservation is important: site, strength, sustainable, scholastic. Before we go to questions and Anne wraps it up, the one thing that I would ask is, I'm always thinking about, you know, why do I do this? Why does this mean anything? Why is this important? I would love to hear from anyone that has you know, gone online and connected with us on this call. If you could share your own thoughts and your own words on why you think preservation is important or is still relevant today, let me know, because the more I you know, have a nice rhyme or reason that connects with people, the more I can get, you know, we can get people to, you know, understand why there's a value here, and we can preserve more of these structures. And again, I think that creates better communities for all of us. So I'd love to hear it in your words. So with that, Ann, I'll turn it back over to you.
Great. Yeah, thank you so much, Lee. I feel like we've covered so much ground in just a short amount of time. And I know we have a few questions that people have posted. Feel free, if you need to leave, of course, you can leave the meeting right at the bottom right of your screen. We won't be offended. If you'd like to stay on to hear Lee answer more questions, we'd love to do that too. And if you do have thoughts about preservation and why it matters, feel free to put those in the chat and we can start that conversation now. One question that we received, Lee, is a little more technical. So Ryan was asking, does the hair change due to the highly alkaline nature of the lime plaster? So when you put the hair in the plaster, does it change?
Does it actually eat away at the hair? I'll say first off, I don't know 100% on that. Let me do some research, because this was back to working with Michael that one time. We were looking at a sample, and it was a sample that there was some hair in it, but not a tremendous amount of hair. And we were speculating whether the caustic nature of the lime just ate away at that hair. So he seemed to think that was possible. But from my experience, I chip samples of this stuff off. I've been looking at samples of this stuff from all sorts of different structures, from a number of different houses and structures. And, I always tend to see the hair is completely intact. Sometimes I'm always curious the size of the grain that they use. So I'll take a sample of plaster and just break it down and look at what sand they use. Was it rounded? Was it jagged? How big was it? Occasionally I'll take little samples. My wife loves this one too. I'll put them in a bag and I'll just label it, and I'll just keep it in the back room or in the attic, just to have some samples of this stuff. But I've got little samples of this old horsehair and old goat hair, and I've got plenty of samples where it hasn't broken down at all. But I'm not 100% sure on that. I'll make a note of that. I'll see if we can get a better answer.
Great. Ryan also had a question about the Bennett Street School. And of course, Michael Burry is one of the faculty members at Bennett Street. And so that is a wonderful place to go if you're looking to learn more about the architectural restoration trades and other buildings like that. So feel free to check them out, and maybe we'll get Michael Burry to do one of these webinars too, because I think there's a lot of great follow-up questions. One of the questions we have from Ken was, do you use native lumber or engineered wood products in your repairs?
So I use native lumber. I prefer, so the LVLs, the engineered beams. Again, this is where I'm not enough of an expert. So much of my, academic, the academic side of the work that I do has been focused on, my passion is first period houses, so older houses. I know there are advocates of, these modern methods of building, and the laminated beams are, I see them everywhere. I can't speak to those. I'm just always a little skeptical of the latest and greatest. And we're taking, now we're taking little pieces of wood and we're gluing it together. Essentially, it's like a plywood. It's laminated. And I know that when stress test is done on those beams, they pass all the tests and they meet the code and they're great. I just don't know enough about whether it's epoxy resins or whatever adhesives or glues they use that hold that all together. Again, wood, this is back to the strength of some of these materials. There's almost a strength in the weakness. Wood expands and contracts and it moves. And sometimes when you have something that's really hard and dense, epoxy and wood repair is a good example, which I will occasionally use. It does have its place, but now we're taking a hard adhesive plastic and we're patching it onto a porous material that will expand and contract, that'll move. And when you have something that's really hard and doesn't move and something that moves a lot, in time, you get failure. So I don't I'm still skeptical. I don't use them. There's a couple sawmills. I won't reveal my sources of where I get my lumber, but there are a few sawmills that I'll go to that I trust that will cut good beams for framing. But yeah, they're mostly using native lumber.
Great. I will just say I did put on the screen my email address is listed there. So if you have any questions that you'd like to send to me or to Lee, feel free to use my email address and we'll hopefully be able to get some answers to you, maybe through another webinar, maybe through just a post on our website. So feel free to send those questions. And then our Antiquarian Society web address is plymouthantiquarian.org. So we do have other upcoming virtual programs and other items on the website that you may find interesting. So feel free to visit there as well. So Lee, another question we had was about finding the earliest paint layer. So how do you test to find the earliest paint layer on a wood panel? That's not something I think you do, but.
No, I don't. There's a company I know. Oh boy, is it? Now the name escapes me. Rose. There are a few companies that will come do historic paint analysis. I've seen. I was in the old Ordinary House in Hingham not that long ago. They hired some folks from the Vernacular Architecture Institute to come in and do some surveying. And when I was in there, I was shown they had some paint analysis done, and I was shown how they do the analysis. And they can do very thorough analysis with taking very, very small samples, so they don't have to scrape huge bits of paint off your historic structure to analyze it and see what's under there. But I don't myself do that. Let me make a note of that. I'll see if I can find a couple names. And that's another thing. For residential homeowners, I also understand that time and budget, it's always a factor. I guess any building project, time and budget's always a factor. But, if you own a historic residential home, you may not have the time and budget to approach restoration as if it's a museum project. But there are things you can do. And this was just something I put on my Instagram page. I'm restoring some windows in my house. And there were probably 4 layers of paint on it. And there was newer latex paint on the top. And it's true, as the paint layers build up, and again, the wood expands and contracts, you get chipping and flaking and it breaks down. And you can't just paint over that because aesthetically it's not going to look great. And it's not going to hold up. So, if you want your next layer of paint to really last, you've got to remove some of the layers. But, there are still things you can do that don't add too much to time and budget that can preserve some of the original fabric and still modernize and update your own residential house. Because if you want to strip a window clean, you can use there's a product called the Cobra. It's an infrared heat gun, or just a regular heat gun. You can get all the paint off, and you can use shape scrapers and get that thing right down to bare wood. But I'm trying to save the original layers of paint because I've got paint probably this is an 18th century sash. So I've got, paint that's hundreds of years old here. I don't just want to strip all that off. So you can just take a carbide scraper and either just give it a light scrape and get as much of the loose flaky stuff off. If that leaves you with too much of a textured surface to paint over, they make some great paint strippers there's one called Back to Nature, and there's a company by the name of Dumond that makes a DUMOND that makes a product called Smart Strip. Smart Strip or Back to Nature it's a paste form. It's low VOC, so it's not emitting toxic gases like methylene chloride. They don't smell. You don't have to ventilate your whole house to use them. Then they're not caustic. They're not caustic like lime. And you can put a light coat of that on your whatever you're restoring, and that'll at least break down the top layer or two, so you can scrape that off and still preserve most of your original paint. When you paint over it, you are going to get, depending on how cleanly you scrape it, you're probably still going to see some of that built up the built up older layers of paint. So there'll be a little texture there. That really bothers some people. They want when they restore things, they want it to look just new, which it's a taste. It doesn't bother me. I find the texture of old plaster, the texture of a few layers of paint, to me, the lines aren't perfect when you do a ceiling with with lath and plaster. Things aren't perfect and square. That bothers some people. To me, those are the little subtle details that really give the place character, that give it this warm feeling. So, I'm okay with that. But yeah, sorry, that was a tangent on stripping paint.
No, but actually,
I don't do paint analysis.
that was great, because you answered someone else's question while answering that question about paint analysis, and it sounds like a great topic for a future webinar, specifically about paint and paint analysis. And we've certainly had paint analysis done here on the Antiquarian Society properties, so we could share some of that information as well. So a couple of other questions that are sort of related. One is more broad. What's the most difficult job or craftsmanship required in building an old home in the colonial period? And then sort of a similar question is, in New England, is any one insect the most damaging for old wood structures? So I don't know if you
The last question, say that again.
In New England, is any one insect the most damaging for old wood structures?
Yeah. I'll answer the first. The big three are powder post beetle, which I'm not an entomologist, but I do a little research. I just have a curious mind. So it's a small, it looks like a little grain of rice. I couldn't tell you the exact size, but they're a small oblong little red shaped beetle. Those, if you see areas of rot where there's just lots of little holes, I don't know, maybe 2 millimeters in diameter, just lots of little holes, those tend to be powder post beetle. And then you've got the more obvious ones, which are termites and carpenter ants. Yeah, those are the ones that'll do the damage. There are carpenter bees. So if you ever see a bee that looks like a bumblebee, but now my bee anatomy is not great. My thorax, maybe basically the bee's bottom, to put it that way. Instead of a bumblebee where it kind of has a fuzzy texture to it, it's got a really black, shiny, round body. And carpenter bees they almost hover like drones, if you're familiar with carpenter bees. We have those, and they'll bore. They tend to mostly do damage on the exterior, so they'll bore into clapboards and shingles, but they bore big, long vertical holes into wood. So that's another one. But to me, you do some damage to the shingles or clapboards. I can deal with that. If you're eating away the frame of my house, that's a bigger problem. So powder post, termites, carpenter ants would be the big ones. Yeah. And I'm sorry, I don't have great solutions to treat it. There's a product called borax. My understanding is it's a natural salt that you can spray, and these insects will, when they're eating the wood, eat it, and it essentially kills them. But I'm not a pest removal professional, so I don't know the going thoughts on borax, and I haven't done any research there. And then the other question was, what's the most difficult? That's the tricky one to answer. I guess we'd have to talk to the builders then, which unfortunately we can't do. I can say personally, stone wall structures, once you understand those kind of basic techniques that I laid out, they're fairly straightforward. Not to say that I'm by any means a master drywall stone builder. I can build a decent structure, but that's fairly straightforward. I think timber framing, and when you get into the joinery, that gets a little more elaborate. If you look at timber framing in Europe, so our examples are with 1637 being the oldest, and Dedham, that's the example that we have to study. If you go back to the 1500s or 1400s, you go to the Middle Ages in Europe, boy, the timber framing there was much more elaborate. And of course, time was a factor, and getting structures up quick with limited resources was a factor for colonial New Englanders. So these structures do tend to be much more simple today. And of course, that's, in my opinion, framing with wood has been on a decline in terms of its strength and complexity. The modern framed houses, new growth, pine 2x4s that again are soft and very prone to rot, and they're nailed together. So if you ask me what's going to last longer, timber frame is better. But if you go look at timber frames in Europe, much more elaborate. But that tends to be challenging. But for me personally, I do a little bit on roofs. The building a chimney straight up. I've never done one of those. That's something Michael's done. I've never done one from the foundation up. That to me would be pretty challenging.
Well, there's a lot you have done though, so your expense. I bet you'll get there someday. Someday. Building that chimney.
Maybe someday. I don't know. I don't think I don't know if I'll have the time ever. I don't know.
Well, maybe since we're approaching 8, we're at 8:30, so maybe this will be the last question here. This is from Kathleen. She says that she's seen several outstanding colonial homes demolished in her town. As a member of the Historical Commission, I have been able to review these homes before they were torn down. Are there places for the old beams to be recycled? Some are extraordinary, and it is difficult to see them destroyed. So maybe that's just a question in general. If a building is being demolished and there's no way to prevent its demolition, can you salvage something? And where would you go with it?
First off, call Michael. We'll have to get Michael's number, because he's your first person to. I realized long ago, as much as I hate to see them come down, I've realized that when you get into salvaging these old structures, it takes a lot of time to take them apart, to label them. You need a place to store them. My wife would not be happy if our lawn turned into stacks and stacks of old framed structures just sitting outside. So I've realized I don't have I hate to see them go, but I don't have the time and resources to save every one of them. So that's not something that I do. Michael would be a better person. He oftentimes can get a crew together, and he'll get a crew and they'll come take them down and try to either find a home for them or resell them, or he'll keep them on his property. So that would be an option. But it's a tough thing. There's we're dealing with that. I'm on the board of the Pembroke Historic Society, and we had the third oldest house in our town, which is 1690, I think, went up for sale, and one of the prospective buyers, fortunately, it got bought by someone that's going to fix it up and rent it out. But one of the prospective buyers was looking to raise the house, and we looked at how do we save this thing. And, we didn't have a fund. Really historic societies and commissions you've got to have some, because the other thing is, I get this too, somebody buys a house and, we see a value of preserving these structures. Some homeowners that don't see that value look at it as it's my house and I don't want a historic society or a historic commission or the town telling me what to do with it. If I want to bulldoze it, I'm going to bulldoze it. I understand that thinking. I get it. You just paid a lot of money for a house. It is yours. I view that as, well, here's the reality with ownership. None of us, I'll come full circle on this to our Tibetan Buddhist monks. Nothing is permanent in life. None of us are going to be here forever. And someday we're all going to be gone, and these things aren't going to be ours anymore. So to me, maybe less selfish attitude is, maybe there is a value to our community, and being a good steward is a better approach. But if you don't tell people, if you don't really show people and hit them over the head as to why there's a value, they're not going to understand it. And maybe if you do make a case, they still aren't going to understand it. So that's part of the reason I do things like this. I think there's a good case for preservation, and I want to make that case. But back to this particular house, we ran into the issue of, well, we don't want to tell the homeowner what to do. And the homeowner, quite candidly, was not a fan of the Historic Society for that very reason. They didn't want us getting in the way of them trying to just sell this house. And they really didn't care about the house. So if we don't have a fund set aside where we can find, a company like Sylvester, if you drive by that structure, I think it's in Hanover, right on 53, that old hardware store that's been up on cement, on iron beams. A company like that can move a structure, but I've heard prices somewhere around $25,000, $30,000 to move a structure. So we were looking into, maybe we could have a company like that come lift it, move it. Now you've got to worry about power lines, and you've got to clear roads, and you've got to get police involved, and it can be done, a structure, and then you have to have a place for it, but it's expensive. So short of telling a home, you can't tell a homeowner what to do because they own it, it's theirs. If you want to save it, my view is you've got to have a fund set aside to, in a case where a house is going to get demolished, to come and pick it up, and you've got to have a place to put it. And then you need to try to generate interest in saving it and find a purpose for it. Short of that, the only other thing you can do is, as a homeowner, is you can do a historic easement. Some people, residential homeowners, don't want to do an easement because they worry that if they do have to sell their house, that's going to affect the resale value, because somebody might not want to buy a house if they're told they can't remodel it, that it has to be kept, to a certain historic standard. So easements are controversial in that regard. But if you don't do an easement on a house, someone buys it that doesn't care, it's going to be bulldozed, and then you're back to, finding someone that's going to just come and just take the frame. And then the other issue with that, it takes time to dismantle one of these structures. So someone that just bought a house that wants to put up a new house, they might not want to wait months to have this structure taken down. So without the town itself regulating it, or without having the means to move a structure, the best thing to do is call someone like Michael that maybe can come salvage it and find a home for it.
Right. Well, as we know at the Antiquarian Society, preservation is never done. It's a job that continues. We moved the Antiquarian Society house, the Hedge House, to save it from demolition in 1924. So the Antiquarian Society was founded to save it from demolition. It took them a few years to actually move the house to a new location, and they had to go through all that. How do we raise the money? How do we find a place to put it? And they had to decide what was the purpose for this house. And they determined it should be a museum. But today, there are a lot of historic house museums. So that question of purpose, I think, is really important for preservationists to decide and to discuss, so that every house is different, every building is different. And you have to have those conversations within the community and with the property owners about what's of value and how can we preserve it, and then how can we continue that work of preservation by making it sustainable and supported in some way. Because you're right, it's a financial endeavor as well as a labor of love. So there are lots of conversations that we can keep having. Thank you, Lee, for sharing with us today. Thank you, all of you who joined us on the Zoom webinar, and we will be sharing the webinar recording so that you can have that and share it with other people if you choose, and that will be on our website. I will send out a follow-up email. After you leave the Zoom meeting, you should be directed to a survey, so if you could take the time to fill out that survey, it helps us plan for more virtual programs like this. But I will send out a follow-up email to all of you about where you can find that recording, and maybe we'll send along some links to some of the books and other topics that we've mentioned. So thanks for being here, and just have a great rest of the summer. Thank you, Lee, very much.
Thank you.